Alright, so we are back again. Now let's move on. In the previous lesson, I forgot to say one thing. A vector has two sides. Alright, a vector has two sides. So a vector has a tail and the head. Alright, so that is where the arrow points. So basically that is that. And a vector must be commutative. I mean, addition of vectors must be commutative. It means that if I have vector A and I add it to vector B, then it should be equal to vector B plus vector A. So basically that is that. So let's move on to some examples. For example, if we have, let's say they give us a question that vector V is equal to 3, 2 and vector U is equal to 1, 4, and they ask us to add them, or we should find the sum. What do you think we are going to do? So this is very simple. We have vector V plus vector U, so we get 3, 2 plus 1, 4. So here I'm guessing you can get the visual representation of what we are going to do. So we have 3 plus 1, and then we have 2 plus what? 4. So definitely we are going to get 4, 6. Now notice something. Vector U and vector V are what? Separate vectors. It means that vector V plus vector U is what? A different vector altogether. So let me say a new vector. I hope you understand. Yes. So vector V plus vector U is a different vector altogether. So how are we going to plot this on the graph? How are we going to plot this on the graph? So we have 1, we have 2, we have 3, we have 4, we have 5, and then we have 6. So let me do this. And then, so of course this is our Y and this is our X. So let's give the, we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, and we have 7. Alright, so let's start with vector V. What was vector V? Vector V was what? 3, 2, isn't it? Vector V was 3, 2. So we are saying that, let's start from the origin. So here you can see that 3 is what? Our X, and 2 is our Y, isn't it? Now let's go to vector U. Vector U is what? 1, 4. 1, 4. So most definitely this is how we are going to go by it, isn't it? Very good. Now look at something. We have two vectors here, vector U, V and vector U, isn't it? Now how are we going to get the other vector or the new vector? Now I have two ways that I can do it. First of all, I told you we have the tail and the head, isn't it? So tail, head. So this is what I'm going to do. I'm going to bring this one, you see this one, I'm going to bring it here. I'm going to continue from here. It means that we add tail to the head. I'm going to add the tail of this vector to the head of this vector and vice versa. Do you understand? Alright. So let's do it. Now keep in mind that with the other one we had something like 4 6, isn't it? So let me do it like this. Now mind you, I'm not doing this with a ruler, so pardon my rough sketches. So this is the 4, isn't it? And then I can also decide to bring this here. Now look at something. You see this vector, the head of this vector is on the 4, right? And here is on the 6, so we have it. Then I can use a long ruler here. Do you understand? And so this is going to be my vector v plus my vector what? U. Now let's move on. This is the idea, or this is where the commutative property will come in. Here I use this, I join this vector to this vector here, isn't it? What of this vector joining this? Of course we can do the same thing here, and then we can decide to rule a line here, isn't it? So basically it's the same thing. So anytime you are asked to plot graphs, plot on the graph vectors or the addition of vectors, know what to do. Alright, and now look at something. I hope what you remember that, or you know that whatever we are doing, it is on the 2-dimension scale. Do you understand? We'll talk about the 3 dimensions later. So I hope you understand.